All right, ladies and gents, this should be the very last video for the practice test for Unit 1. So let's go ahead, let's just get started. And let's start with number 18. We are just graphing the inequalities on a number line. That's it. Should be pretty easy. So, I'm going to draw some number lines. The one number you need to make sure is on your number line is the target number, the number that we're actually comparing x to. So here we are comparing x to -4, so we're going to put -4 in the middle. One number that is larger than -4 would be -3, and one number that is smaller than -4 would be -5. So three numbers, we've got something to compare to, we should be good here. Just a misconception that I've had with a lot of kids is that, oh, 0 has to be on the number line and it has to be in the middle. It does not. We are never looking at an entire number line. There's no way to look at an entire number line. So we're always looking at just a snippet. We're used to seeing 0 in the middle because we're used to talking about adding and subtracting negative and positive numbers. And we're just kind of used to seeing 0 in the middle because it is like a good starting place is to have 0 in the middle and be able to go to the left and to the right. But for our purposes, we don't need to list every single number all the way out to 0. That's kind of redundant. We just need our target number and then a number larger and a number smaller. Also, I've had some people say, no ma'am, -3 is smaller than -4. But if we think about it, if you think about it in terms of money, who has more money, the person that owes $4 or the person that owes $3? You could make the argument, well, they owe money, so neither one of them have it, but this person's less in debt, so he's got a little more money than this person because this person is more in debt. I don't know if that helps anybody. That helps me, and I know a lot of people who like, oh, I can't math, oh, but I can money, so, you know, maybe that helps people. We'll see. All right, so I'm always going to put a circle over my target number, and then we'll look at this. This says that x is greater than -4. So numbers that are greater than -4 would be -3, 0, +20. Everything to the right would be greater than -4. So if x is greater than -4, we're going to go to the right. Now I need to decide if this circle is going to be opened or closed. And the way I decide that is if my inequality symbol has an equal to bar. If it has an equal to bar, that means it includes this number as a solution. If it does not, then we don't include it. So this is not included as a solution. -4 is not greater than -4. So I'm not going to color this in. Okay. B, x is greater than or equal to 0. Then do kind of a little number line. We're going to have 0. A number larger than 0 is 1. A number smaller is -1. And when I say a number larger and a number smaller, we want to keep these spaces really even. So I always typically go one up and one down, or one larger, one smaller. What you don't want is like a -1 to have the same distance as like a 10. So if I were to put like -1 here and a 10 here, your number line wouldn't be correct because you're saying the distance, you would have the same equal distance, but like the numbers would not be equal, and it may not seem like a big deal. It may seem nitpicky, but when you start trying to compare ranges and compare numbers and compare inequalities, if your number line is not scaled correctly, or if a graph isn't scaled correctly, you can't make accurate comparisons. So yeah, it seems like I'm just being a jerk right now, but I promise you it's to help you get better and to help you, honestly, the more careful you are, the better you are at making like comparisons. So we're just going to be careful about things. So this is greater than or equal to. So I'm going to color my circle in. It's going to be a closed circle because 0 can be equal to 0. It's greater than or equal to itself. So we're going to include it. So we'll color it in. It's a closed circle, and again, greater than goes to the right. All right, so C, x is greater than or equal to 3.5. So what I like to do here is if I've got like a fraction number in there, let's do this. We're going to do 3.5. We'll do 3 on this side, and we'll do 4 on this side. That's so much easier than doing like 2.5 and 4.5. I don't know why I like that better. Does it really matter? No, but you know, that's one of those things that makes me happy. So It is a less than or equal to symbol, so it will be a closed circle. And since it's less than, numbers less than 3.5 would include numbers like 3 and 2 and the negatives, so we're going to keep going to the left. All right, and finally we have D. X is less than -2 and 2/5. So, yay, I know fractions, your favorite thing ever. Yay, fractions. Okay, so what we're going to do to make this a little bit easier, when we number line this, so this is -2 and 2/5. So, a number larger, so remember, we're on negative, so it's going to feel backwards. Let's just do -2 and 1/5 and -2 and 3/5. Okay, yeah. So that's good. You can just do your fifths. Again, we're just going for something larger and then something smaller, and I like for them to be equal length. You don't have to go like a whole number. You don't have to do a -3 and -1 and a -3. You can just like change the the numerator. Man, I've been talking for a while, so I keep tripping stuff up. Okay, so we're going to do an open circle because this has not got an equal to bar. So open circle, it's less than. We're going to go to the left. And I think most of you guys are good with the graphing. I think some people get open and closed circles mixed up, but equal to is the closed circle. Open is for the just regular less than or equal to, or less than or greater than. So this helps. If this helps somebody, I don't know. We'll see. Okay. Number 19. Grace has $16 to buy a gallon of milk and some apples. The gallon of milk costs $1.59 and the apples cost 75 cents each. Write an inequality Grace could use to find out how many apples she can buy. So let's look. I think I've used this example before. If your mama sends you out to buy milk and apples, you have to buy that milk. If she sends you out for milk and you don't come home with that milk, you're getting a whooping. Like, there's just no way around that. You're getting a whooping. So we're going to include that milk first. Or maybe just my mama would have given me a whooping, but, you know, I'm just going to put that out there. So I'm going to make sure I have that $1.59 for milk no matter what. Okay, so then I have my apples that I want to buy. So I'm going to add the cost of the apples to that. So we're going to do 0.75 times however many apples I get. Now here's the deal. I only have $16. So you have to think, can I spend more than $16? I don't have more than $16, so I can't spend more. I could spend less, but I can't spend more. So what I spend has to be less than or equal to $16. I can spend exactly $16. My mom would not have been happy about that, but you know, I could do it. It's a possibility. But I can't spend more than $16. They're going to make you put stuff back at the grocery store if you come up with more than, if you try to buy more than what you have money for. Excuse me, guys. Okay, sorry about that. I record these at school while other people are here, so if there's some crazy interruptions and stuff, I do apologize. I'm trying to do the best I can with that. Some things I just can't help, though. Okay, so if we're looking at this, I've got my milk, I've got my 75 cents per however many apples, and I've got it set up to where it is less than or equal to the amount of money I have. So I don't think it's actually asking us to solve it. I think it just wants us to write the inequality. And this is a good inequality. This is what we would want. So less than or equal to $16. Okay. Number 20. Now we're getting into some solving. So when you solve an inequality, there's only one thing different between an inequality and an equation. I'll get to that in a second. But really and truly, you proceed just like with solving an equation. There's not, your steps and everything should be exactly the same. So just like in an equation, the first thing I think I would do would be to distribute that -3. Just make my life a little bit easier. So I have 8 minus 3x. And then -3 times 6 would be -18. And this is less than or equal to 72. Okay. Let's make me have fewer numbers. So I have an 8 and a negative 18. I'm going to combine like terms. 8 minus 18 would give me negative 10. And that's still less than 72. All right, we're trying to get x by itself. I'm going to take away the furthest thing away from x that's not on this side, and that would be that 10. So we're going to add 10 to each side. And what that gives me is negative 3x is less than 72 plus 10 is 82. Okay, so for the fun part, we are going to divide both sides by a negative 3. Okay, let's see. I don't know that that will divide evenly. Let me check. It does not, so we're just going to leave this actually as 82 over negative 3. It doesn't simplify. And I'm okay with improper fractions. Improper fractions do not bother me. In fact, I think improper fractions are sometimes a lot easier than decimals and mixed numbers. And that could just be my warped and twisted brain. But you know what? It is what it is. Now, I will say this. We divided by a negative. When you divide by a negative, it does change which side is greater and which side is less. So we need to swap our inequality symbol to account for that. And I did not draw my box big enough, so we'll do it like that. So my solution is x is greater than negative 82 thirds. If you want to check and make sure you got a decimal right, like if you got a decimal answer and you want to make sure that's right, that would be x is greater than negative 27.3 repeating. Personally, I prefer the fraction. I know, like, I'm one of the weirdos and one of the only weirdos on this planet that prefers fractions, but it is what it is. Okay, 21. Graph the compound inequality on the number line. X is greater than negative 2, and x is less than or equal to 4. So let's think about this. Are there numbers that could be greater than negative 2 and less than 4? Yeah, like 0 is larger than negative 2 and less than 4. 2.9 is greater than negative 2 and less than 4. So when we graph these, so this is all the things that would be in between these two numbers. So when we graph it, we need to make sure we have both target numbers on our number line. So let's see how many tick marks I can fit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right, perfect. So that I personally, you don't have to do this. I personally like to have like one number on either side of my target numbers for wiggle room. It's not that big of a deal, but you know, you can do it. Okay, so x is greater than negative 2. So I'm going to put a circle on negative 2. It's greater than, not greater than or equal to. So this is open. X is less than or equal to 4. So I'm going to put circle on 4. It has an equal to bar. So I'm going to fill it in. So this is x is greater than negative 2, which goes this way, and x is less than or equal to 4, which goes this way. So we're including all the variables or all the numbers in between these two target numbers. So anything in this range is a solution to the compound inequality. Okay, number 22. We're going to solve this disjunction. We're going to solve this. It's got an or. It's a disjunction. It has an or. So we are, if we think about it, if we have to graph it with it being an or, it should look something like this. You should have like a, I don't know if they're open or closed, but depending on what this does, but should be split apart because it's a disjunction. Remember, these right here are called conjunctions because they are connected. It's two things that can happen together. These don't typically happen together. It's something you could be this way or this way. This way you can go to the left and to the right. This is like go to the left or to the right. Okay. All right, so when we solve the disjunction, this is like having two separate problems that we solve each of them, and we graph the solutions on the same number line. So when we solve this one, we're going to solve the disjunction first. We're going to subtract 5. We have 3x is less than or equal to 6. Divide by 3. X is less than or equal to 2. So I'm going to write this to the side. X is less than or equal to 2. And then on our other one, I'll do it in a different color. We're going to distribute the negative 5 and have negative 5x plus 10 plus 8 is less than negative 17. I have negative 5x. Going to combine like terms to get plus 18. It's less than negative 17. Subtract. I realize I'm kind of running through this quickly, but I think I've spent over an hour recording stuff today, so bear with me. I do apologize if I'm getting on people's nerves, like with how quickly I'm going. So I'm going to combine these. 17, negative 17 minus 18 should be 35, so negative 35. I'm going to divide both sides by negative 5. And I should get x is, oh, wait a minute, I divided by a negative. When you divide by a negative, you flip your sign, so x is greater than 7. Put that here. So over here, I have x is less than or equal to 2, and x is greater than 7. I'm not sure, it didn't ask us to graph it, but let's go ahead and do that anyway so we know what it should look like. 2, 3, 4. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8. All right, so x is less than or equal to 2. Close circle on 2. Less than goes to the left. X is greater than 7. Open circle to the right. And there we go. This should be our disjunction. Okay. So 23. Number 23. It asks us to solve the absolute value of x equals 9. So remember, when you take the absolute value of a number, you could take the absolute value of a positive, and those absolute value bars make that number positive, so absolute value of positive whatever equals positive whatever. Absolute value of negative, those absolute value bars make it positive, so the absolute value bar, or the absolute value of a negative whatever would still give you a positive whatever. I don't know if that was confusing or not, but basically what that tells me, if I put positive 9 in for x, the absolute value of positive 9 is 9. The absolute value of negative 9 is also 9. So when I go to solve this, basically what I'm saying is x equals 9, x equals negative 9. So when you go to, like, Ms. Gallant, how do you solve that? Well, remember, if this were a more complicated equation, you would take this complicated equation and equal to 9, and you take that equation and equal it to negative 9, and then solve it like a regular equation. Since there really weren't any steps to it, it was just kind of understanding what absolute value does. Really and truly, there's not really any steps to this one, other than just remembering the absolute value makes things positive. So your x could be a positive 9 or a negative 9, and both of those would give you a, like when simplified, would give you 9. All right, so 24 is kind of like what I was saying with that complicated equation and setting it equal to positive 33 or negative 33. We're going to do that, but it is an inequality, so we have one extra step. So once you have an absolute value bar, to get rid of those absolute value bars, you take your equation, or in this case your inequality. You have the inequality that they gave you, the less than 33. But then you're also going to take what's in absolute value bars and set it equal to, or in this case, you're going to make this side negative. Now, just like we did with dividing by negative, whenever you change the sign of one side, that does change your inequality. That changes what you're, like, which side's greater and which side's less. So now we're going to also have is greater than negative 33. All right, so I'm going to solve it just like a regular equation or a regular inequality. I'm going to get x by itself. Let's add 12 to both sides. X is less than 45. Here, add 12, add 12. X is greater than negative 21. Okay. All right, and again, if you were to graph this, let's see, you can have numbers that are greater than negative 21 and less than 45. So this would be a conjunction. It would be connected. It would look similar to 21, just over different numbers. All right, and then 25, the last problem. Whoop, whoop. Last problem. So, our main goal is to get the absolute value bars by itself. Well, our absolute main goal is to get x by itself. But before we can split this into two, let's get the absolute value bars by itself. So we can subtract 2 from either side. And we should have 3 is times the absolute value of x minus 7 is greater than or equal to 18. Okay. I have gotten this question a lot, and I've always said, I will look it up, and I finally looked it up. I got asked, can you distribute into absolute value? And so I found out that you can distribute into absolute value half the time. You can distribute if this number is positive, but if this number is negative, you cannot. So instead of like trying to remember when you can and when you can't, let's just assume you can't. Honestly, this is kind of easier to me anyway. We're going to get rid of the 3 altogether by dividing. And why I like this, if you distribute, first off, you'll have to divide it later because you'll have a 3 times x, and so you'll have to divide later. But if you distribute, it makes these numbers bigger, and so you're dividing bigger numbers. And I don't like that. Let's just go ahead and divide and have smaller numbers all around. So now I have the absolute value of x minus 7 is greater than or equal to 6. Easier numbers. All right, so again, now I've got the absolute value by itself. I can have the absolute value of a positive and get a positive, or the absolute value of a negative and get a positive. So what we're going to do is we're going to split this into 2. I have x minus 7 is greater than or equal to 6. I also have x minus 7 is less than or equal to negative 6. Okay. Getting x by itself, we're going to add 7 to each side. X is greater than or equal to 13. Add 7, I get x is less than or equal to 1. So it also says graph. So I don't have a word in there telling me if it's a conjunction or a disjunction. I don't have an and or an or. So I have to think about this logically. So numbers that are bigger than 13, greater than 13, are there numbers that are greater than 13 that are also less than 1? And the answer to that is no. Like, numbers that are greater than 13 would be 14. Well, 14 is not less than 1. 15. Well, 15 is not less than 1. All right, numbers that are less than 1 would be 0. 0 is not greater than 13. This is a disjunction. You can't be greater than 13 and less than 1. If you're thinking about, and I know this is silly, think about like age. You can't be a teenager and a baby at the same time. Like, you can't be younger than 1 and greater than 13. It just doesn't work. So we're going to graph it. Let's see, 1, 2, 3, 4, 5, 6. Okay, so let's do 1, 3, 5, 7, 9, 11, 13, 15, 17. All right, I went with just the odd numbers, and that's okay. I'm not liking how this is so off-center, and I don't like it. But doesn't mean it's incorrect. No, that just means you're Miss Gallant's OCD. All right, so x is less than or equal to 1, so we're going to color it in. It's a closed circle, and since it's less than, we're going to go to the left. X is greater than or equal to 13. Again, closed circle, and it's going to go to the right. Okay. Man, we are done. So if you have any other questions, feel free to email me or Miss Means, depending on who your teacher is. I hope this video was helpful. I know I kind of got quick there at the end, but man, my throat is tired. Like, this was a long practice test. And I know y'all are thinking, yeah, it's long and you assigned it to us. What were y'all thinking? But, you know, we were hoping this was helpful. I hope this video is also helpful. And so, yeah, just holler at us if you have any questions. And I hope you guys have a great evening. And those of you that are retaking the Unit 1 test, good luck to you. And hope you get some good study time in. And we're going to do better this time. There's no hope. We are going to do better. Okay? All right. So y'all have a good evening. Thanks for listening. And bye-bye.